In today's lesson, we are going to be looking at collecting like terms. So we're going to define what a like term is, we're going to explain what collecting them means, but before we get into that, we're going to do a little bit of a warm-up that might help make this concept a little bit easier to understand. So I've gone around the school and I've taken a Tim Hortons order for all of the staff. So I want you to listen to the order and copy it down. Right? If you're just going to do, you can do this on a scrap piece of paper or just any paper, or just try to write this down or try to remember it. So the order is a large coffee double-double, a large coffee double-double, large black coffee, tea with milk and sugar, large coffee double-double, a maple dip donut, another large coffee double-double, a large black coffee, a large regular coffee, a large coffee double-double, 10-pack of Timbits, large coffee double-double, tea with milk and sugar, another 10-pack of Timbits, large regular coffee, large black coffee, large regular coffee, large coffee double-double, large black coffee, 10-pack of Timbits, large regular coffee, and a small black coffee. Did you get that order? Right. I'll go through it once more, and I'll try to slow it down a little bit to help you out. But maybe try to change up your strategies at how you can take this order. So, the order is large coffee double-double, large coffee double-double, a large black coffee, tea with milk and sugar, large double-double coffee, maple dip donut, large coffee double-double, large black coffee, large regular coffee, large coffee double-double, 10-pack of Timbits, large coffee double-double, tea with milk and sugar, another 10-pack of Timbits, large coffee regular, large black coffee, large regular coffee, large coffee double-double, large black coffee, 10-pack of Timbits, large regular coffee, and a small black coffee. Did you get the order that time? If not, think about what strategies I could use, or maybe you could use, to help make it easier to write down this order or keep track of it. Is there a way that I could arrange the items a little bit better? Or is there a way that you could work through kind of making it easier to keep track? Right? So think about what strategies you, if you were able to get the order, think about what strategies you used. Or if not, think about what strategies you might use to make it a little bit easier to record this order. As well, you can see a video on YouTube as well. There is a Mad TV sketch very similar to what we just did, maybe a little bit more funny than ours. But again, you can go and check that out if you wish. So we are going to look at some terminology before we get into the idea of collecting like terms. So again, we have a couple things here. We have a coefficient, a variable, an exponent, and a term. A coefficient is just another word for basically saying a number. A variable, we've talked a little bit about. It's a letter used to represent a certain value. So we might not know what that value is yet, so we just use the letter as a placeholder. An exponent, again, we've definitely talked about exponents before. Exponents is the number of times a base is being multiplied. It's raised, it's usually a little bit smaller when we're writing it. And a term is a product of a coefficient and variable part. So a term is basically something that's multiplied together, a coefficient and a variable. So if we look at our example here, 4x squared, we have all of those parts. So we want to make sure that we kind of identify them, just so we get an understanding of what we're looking at. So a coefficient is the 4 in front. It's a little bit smaller. So coefficient is this 4 out front. The variable, that's the easy one to see, it's the letter. An exponent, we've definitely talked about before. It's the 2. And this entire thing here, this entire thing is considered our term. So the 4x squared entirely is our term. Like terms are terms whose variables and their exponents are the same. So when we talk about collecting like terms, we're going to be looking for terms whose variables and their exponents are the same. So if they're the same, that's considered a like term. And we'll look through some examples of that. Unlike terms, simply terms that are not like terms, so just the opposite. So if their variables and exponents are different, they're considered unlike terms. And expressions that have like terms can be simplified by collecting like terms. So collecting like terms is a way of simplifying an expression, and we do that by adding or subtracting. So for example, if I look at an expression similar to, or a visual expression, right, we have an order here for a fast food place. We have 2 burgers plus a french fry plus a pop plus 3 more burgers plus 2 french fries plus 2 pops. Is there a way that I can collect these like terms to make this order easier? Or in other words, similar to the Tim Hortons question, is there a way I can order or arrange my order to make it a little bit easier? Can I simplify it? Well, I can kind of combine all the things that are considered the same. So I can combine my burgers together. So instead of saying 2 burgers plus 3 burgers, I can just say 5 burgers. Or I'm going to say 5B just to make it a little bit simpler. B is the unknown, or B is what I'm identifying this as, 5 burgers. Plus, I can combine my french fries together. So 1 french fry plus 2 french fries is 3 french fries, or 3F. And then finally, I can put the pops together and say 3 pops, or 3P. So this is how we can simplify our expression by collecting like terms. We're grouping the things together that are the same. Now this is a visual, so it's not quite going to be the same with actual terms, but this is to help us get used to that idea. Here, in this example, in each set of numbers, we want to circle or highlight the like terms. So this is where we're really going to focus on the specific definition for a term. And again, a like term has the same variable and exponent. So if I look, say my first one, 2x, do I have any other terms that have x? Well, I have a 5x, a 6xy, and a 4x squared. In this case, though, it has to be exactly the same. So if the variable is x, then in the other terms, the variable has to be x and only x. So that takes out the last two, because this has xy. In this one with the 6, that has xy. And in this one, we actually have x squared. So the exponent is not the same. So that one's not the same, or a like term. So that means only 5x is a like term with 2x. If I look at the other remaining terms, 2, 6xy, 4x squared, those don't have, or there's no like terms between them. They all have different variables or exponents. If I look at set B, again, I'm going to go through and look for terms that have the same variable. If I start with the first one, 9y squared, do I have any other terms that have a y squared? If I go through 10xy, it has a y, but it's not squared, and it also has an x, so that's not a like term. Negative 4 has nothing. Negative 3y squared does have a y squared and only a y squared. So that makes it a like term with 9y squared. Do I have any other like terms? Well, I have a 10xy term. Are there any other terms that have xy? Nope. So 10xy isn't a like term with anything. I have negative 4, and basically just a number. Is there any other term that's just a number? Well, I do have 20. 20 is just on its own. So because it doesn't have a variable, that makes it a like term with negative 4. So I have two pairs of like terms in B. Now we're just going to look through some examples. We're going to start off again visually and then work our way into just dealing with numbers and variables. So 6 cookies plus 2 coffees minus 5 cookies plus 4 coffees. Again, when we're dealing with like terms, we want to focus on the parts that are the same. If it's easier, use a highlighter or underline your like terms. So identify your like terms first. So if I start off with 6 cookies, actually I'm just going to underline it to save some time. 6 cookies, I also have minus 5 cookies. Those are like terms. They're both cookies. 2 plus 2 coffees plus 4 coffees. Those are like terms. They're both coffees. So if I go through and simplify this, focus on the parts that are the same. 6 cookies minus 5 cookies. Well, that's the same thing as just saying, well, there's 1 cookie. We're going to say 1C. Plus 2 coffees plus 4 coffees. I can combine those together and say, well, I have plus 6 coffees. Let's say D for drinks instead, because we don't want to mess it up with C because it is something different. So again, that's collecting like terms. I've combined what I've looked at, or I've combined my items. So we use C for cookie and D for drinks. If I look at the next one, a little bit more complicated because now I have multiple variables, you could say. 4 coffees plus 3 donuts plus 2 cookies minus a coffee minus 3 donuts plus a cookie. Again, let's go through and underline or find our like terms. 4 coffees minus a coffee. There's no other coffees. 3 donuts minus 3 donuts. And 2 cookies and plus 1 cookie. Let's go through now and collect our like terms. So let's combine or simplify some things. If I have 4 coffees minus 1 coffee, I can just rewrite that and say I have 3 coffees, or we'll use D for drinks, similar to the last one. Plus 3 donuts minus 3 donuts. Well, if I have plus 3 and then I have minus 3, it cancels out. The donuts are gone. There's no donuts in general. Plus 2 cookies plus 1 cookie. That gives me plus 3 cookies. So again, I've simplified my order. I've made it easier by combining the things that were the same. Let's look at an expression now. So if we want to simplify the following expression, again, we're going to do the same thing. We want to find our like terms. So let's go through and find our like terms. We'll start with 2x squared. Again, remember a like term is one that has the same variable and exponent. So even though we see some terms that have an x as well, look at the exponent. Is it the same? Is it a 2? We should find there is only one other like term, negative 3x squared. If I look at negative 4x and 2x, those are like terms because they both have an x. And then finally, negative 5 and 2, they're both like terms because they're just numbers. Once I've found all my like terms, I need to combine them. So if I have 2x squared minus 3x squared, combine them and I get minus 1x squared. Remember, as we're going through this, we want to make sure that we're not changing the variables. We're not changing that part of our term, right? Because you can think of it, that's our item. We're not changing the item, we're only changing the quantity or number of them. So we're only changing the coefficient. So I have negative 1x squared, and I look at the next set of like terms, negative 4x plus 2x, negative 4 plus 2, I get negative or minus 2x. Again, I'm not changing the base, or sorry, the variable, I'm only changing the coefficient. Finally, negative 5 plus 2 is negative 3. So again, that is where we get our simplified terms or expression. I've combined my like terms. In this case, there's no other pairs of like terms. We only have one of each, so I don't need to go any further. There's nothing else I can do to simplify this. If I look at a longer example, again, even though it's longer, we're still doing the same thing. We're going to go through and try to find our like terms. So we have 3u. Do we have any other terms that have just a u? Again, we have some that have just a u, but it's squared, but that's not a like term. It has to have the same variable or letter and exponent. So we go through, we should find that at the end, plus 2u is our like term. Let's go to the next one, negative 4u squared. And go through, I find a minus 2u squared. So those are a pair of like terms. One thing to keep in mind, make sure you include the sign in front, because that's going to tell us what we have to do. Are we adding or are we subtracting? The sign in front will tell us that, so we need to include that when we find our like terms. Positive 5, negative 7. They both don't have letters, so they're like terms. Negative 6uv and 4uv. Those are like terms. They both have a u and a v variable. Now that I've found my like terms, we're going to go through and we're going to collect them. So let's start with 3u. 3u plus 2u is 5u. Negative 4u squared minus 2u squared is minus 6u squared, or negative 6u squared. Again, you're only adding the coefficients. Plus 5 minus 7, you get minus 2. Negative 6uv plus 4uv is minus 2uv. So again, I'll underline my like terms. And we should see, actually I should be putting equal signs here, saying it equals the above expression. Let's move this over a bit. So again, once we've collected our like terms, we can always do a final check. Do I have any other pairs of like terms in my expression? I do not, so that means that I've simplified it as much as I can. Let's move on to a different type of example. Here we're going to be looking at a figure, and we want to determine the perimeter of the figure. So if I look at my triangle, I want to find the perimeter. So remember, the perimeter is the distance around. So it's the distance around the object. So basically it's adding up this side, and this side. So if I'm adding them up, I'm just going to write this all out. So the perimeter is equal to negative x plus 5 plus 2x plus 1 plus 4x minus 7. Once I've written out my expression, I want to collect this. I want to simplify this to make it a little bit nicer. So I'm going to go through and I'm going to highlight or underline my like terms. So I see a negative x, I see a 2x, and I see a positive 4x. Highlight that positive from the 2. So those are all like terms because they all have the same variable x, and that x has the same exponent, 1. Let's look at our other terms. Well, I have a plus 5 is that a like term with anything? It's a like term with 1 because it doesn't have a variable, and the minus 7. So once I found all my like terms, I'm going to go through and add them or collect them. So minus x or minus 1x, right? Remember there's an invisible 1 here. So minus 1x plus 2x plus 4x. So minus 1 plus 2 plus 4, we should get 5x. Again, we're not changing the variable. We're changing the coefficient or the number in front. And then 5 plus 1 minus 7 is minus 1. So with the numbers, it's a little bit easier because there's no variables involved. We're just adding our numbers. The next part says, what would the perimeter be if x equals 4? Now, we do have a simplified perimeter, so when x equals 4, I can take p equals 5x minus 1 and just replace the x with 5. So 5 times 4 minus 1, I get p equals 19. So this is similar to the substitution, which we've done before in a previous lesson. The other thing you could do, if you weren't confident with your collecting like terms, go back to the original shape, replace x with 4, and solve each one. Right? That would still give you the same answer in the end. So if you're not confident with your collecting like terms, or you want to double check your answer, that is one way to do it. So there are workarounds if you're a little bit unsure. We'll look at one last example. Determine the perimeter of the figure. So we have a rectangle here. We have expressions for the sides. And again, once we find our perimeter expression, we want to come up with what the actual perimeter is when x equals 4. So again, perimeter is adding up all of the sides. Here we're only given 2 sides, but because it's a rectangle, we should remember that the opposite sides are equal. So even though we're not given the other 2 sides, we should still know what they are. I'm just going to write out all the sides. So x squared plus 1 plus x squared plus 1, because there's 2 of them, plus 3x squared minus 5 plus 3x squared minus 5. Again, I've written out my expression. I'm going to go through and collect my like terms. I have x squared that I can add with x squared. I also have a 3x squared, which is a like term because it shares the same variable and exponent. I have 2 of them, so I can add those together, remembering to include the sign in front so I know what type of operation I need to do with it. And I look at my other terms, plus 1. That's a like term with plus 1, minus 5, and minus 5. They're like terms because there's no variable attached to them. Once I've found my like terms, I'm going to collect them to make it simpler. So that's where we look at the individual parts. So x squared plus x squared plus 3x squared plus 3x squared. Again, in front of the x squareds, we have to remember that there's an invisible 1. Right? There is 1 there as a placeholder. We do have 1 of the item. So x squared plus x squared is 2, plus 3 is 8. So I have 8x squareds. And then with the numbers, 1 plus 1 is 2, minus 5 is negative 3, negative 3, minus 5 is negative 8. So again, the numbers we just add as normal or subtract, depending on the sign again. So we get 8x squared minus 8 as my simplified expression for the perimeter. Now, what I can do is I can take that expression, p equals 8x squared minus 8, plug in the 4 for x, and solve. Because again, the second part of the question is saying what would the perimeter be if x equals 4? So we have 8 times 4 squared minus 8. and we get the perimeter is equal to 120. Again, we could go back and we could plug in 4 into our actual side lengths and find out what they were and then add them all up. But we did want to find or work on our collecting like terms by coming up with a simplified expression first, because it may not be, or x may not always be 4. X may be something else depending on the situation. So it might be easier to have that simplified expression first and then plug it in, rather than plugging it into all the other sides and going through all those calculations every single time. But again, the big thing from this lesson is understanding what a like term is, being able to identify it, or identify like terms in an expression or just in a set of numbers or set of terms, as well as then being able to collect them or simplify an expression by collecting like terms. Again, if you're ever confused, think back to that Tim Hortons question or the visual expressions that we dealt with, right? Because that might help with having a better understanding of what we're really doing.